In this video, I'll be helping you with the ALEKS problem type called graphing a hyperbola given its equation in standard form. And we'll start by recalling that there's two versions of standard form for hyperbolas. The first is when the x term is first ahead of the subtraction. This gives us a horizontal transverse axis. So these hyperbolas open left and right. And then for the second version of the standard form, we of course still have subtraction and still have the a squared on the left and the b squared on the right. We now have the y minus k squared first and the x minus h squared second. This will give us a vertical transverse axis and a hyperbola that opens up and down. And for this example, it is the second case here. This will give us a vertical transverse axis opening up and down. And to graph, I'll start by finding the center. We know that our center is the point HK. And from standard form, h is what's being subtracted from the x. So in this example, we're subtracting -5. And k is what's being subtracted from the y. Here we are subtracting 2 from y. So our center is -5, 2. So I'll go to -5, 2, and I'm going to go ahead and sketch that transverse axis up and down from here. And again, I know that my graph will look something like this. We've identified the center. From here, I'm going to use the A's and the B's to draw a rectangle around the center. I'm going to start with the B. I can see here that b squared is 9. So b is 3, and b is underneath the x variable. So in the x direction, I'm going to move 3 units to the right from the center and 3 units to the left from the center. And then I would like to find a, and a squared is 16. So a is 4, and a is under the y variable. So I will go up and down 4 units. And now that I've moved left and right and up and down, I can connect all of these points into a rectangle. And the nice thing is that now that I have this rectangle, I can connect the corners of the rectangle and that center point to form my asymptotes going diagonally in both directions. And from here, I can identify the vertex along that transverse axis on the top and approaching these lines asymptotically. And the same on the bottom, we have our second vertex. And again, approaching these asymptotes. We have used all the information in standard form to graph this hyperbola.